Good morning to all. I am Subramanian, working as an assistant professor in automobile department in SNS College of Technology. In this session, we are going to see about the electronically controlled gasoline injection system for the SI engines, that is spark ignition engines. So, an electronically controlled gasoline injection system in the spark ignition engine is a sophisticated mechanism designed to deliver the precise amount of the fuel into the combustion chamber at the right time. It improves fuel efficiency, reduces emission, and enhances engine performance compared to traditional carburetors. So, whenever the electronic controlled gasolines will be injecting the fuels at right time to the precise amount, not the accurate amount, precise amount of the fuels. In this, we see about the components of the systems. The system comprises of several components that work together under the electronic control. There is electronic control unit (ECU), sensors, fuel injectors, fuel pump, and fuel rail, and other components of that. We see one by one in detail. The electronic control unit (ECU) is the brain of the system. It processes input from the various sensors to calculate the optimal fuel injection parameters. And sensors, there are various sensors there. One is a mass airflow sensor, measures the amount of the air entering the engine. Next one, manifold absolute pressure (MAP) sensor monitors the air pressure in the intake manifold, and throttle position sensor tracks the position of the throttle valve. An engine coolant temperature sensor monitors the engine temperature for a cold or hot start adjustments, and oxygen sensors measure the oxygen levels in the exhaust gas to fine tune the air fuel ratio. Finally, crankshaft position sensor which determines the engine speed RPM and piston positions. Next is the fuel injectors. So, electromechanical device that sprays the fuel into the intake of the manifold or directly into the combustion chamber itself. Fuel pump and fuel rail. The fuel pump delivers the fuel from the tank to the injectors at high pressure. The fuel rail distributes the pressurized fuel evenly to the injectors. And the other components are the idle air control valve and fuel pressure regulator. So, adjusting the intake during the idle conditions, and also fuel pressure regulator maintains the consistent fuel of the pressure. How it works, working principle we see about it. So, first it collects the data collections and ECU, electronic control unit processing, fuel injection, feedback adjustments. All these having the working principles there. So, data collections, sensors gather data about the air intake, throttle position, engine speed, temperature, and exhaust gas composition. ECU processing, electronic control unit process the sensor data and uses the pre-programmed maps or algorithms to calculate the optimal air fuel ratio. Usually, it must be 14.7:1 for the gasoline engines. And fuel injector, the ECU control unit controls the injector to spray the precise amount of the fuel into the intake manifold, port injection, or directly into the cylinder based on the engine requirements. And we have the types of injection systems: port fuel injection system, direct fuel injection system, and finally see about the advanced applications of the electronically controlled spark ignition system. So, the port fuel injection system injects the spray fuel into the intake manifold near the intake valve itself, whereas the direct fuel injection system, fuel is injected directly into the combustion chamber under high pressure, which offers the better fuel optimization. The advantages on this electronic controlled gasoline engines: precise control, fuel efficiency, emission reduction, and performance of the cold start capability also there. So, the electronic controlled gasoline injection system has a revolutionized in the spark ignition engine operations, ensuring precision, efficiency, and compliance with the emission of the standards. The emission standards, its adaptability to varying the driving conditions make it a conversions of the modern automotive technology. With this, we will come to the end of the session. Thank you.